About 1 and 2. So what I'm seeing is exactly what I was nervous about, is that after we did the lesson about GCF and we went into everything being 2 binomials, and everything y'all are wanting to make 2 binomials. It's not the case. What can you factor out from number 1? At 2x, there's more than that. Negative 2x. You don't want a leading term that's negative. So I'm going to factor out negative 2x from both terms. Now, when you factor out, I had a really good question, a conversation over on the side of the room. If I'm factoring something out and it's just an expression, your answer needs to be able to be distributed to make it look exactly like it was. So we can't just get rid of it. It's negative 2x times what? X minus 4. Make sure that everything that you have factored out stays out in front. Huh? I factored out an x, so it's not squared anymore. Okay, so this is my answer. That's all I can do. That's it. Because now all I have left is x minus 4. You can't factor that further. Okay, so then number 2. What I'll do first? 3. 3x. Good. 3x. So my 3x is now in front because I'm not solving, I'm just factoring. And what's left on the inside?
4x cubed plus 3x.
4x cubed. X squared plus 9. Now, I had a lot of people trying to factor that further than that. Everything that we turned into 2 binomials was a square, a 1, and a constant. I can't factor this the way that it is. So this is my answer. Okay. Once you factor out a GCF, and you make sure, guys, once you factor out a GCF and you make sure that your leading term is now positive, if that's all you can do, then it's factored. Factoring out a GCF counts as factoring. It doesn't have to be like that. Okay? Now, this problem, there's 2 word problems on the quiz tomorrow, but they are not nearly this difficult, but there are some that are going to be this difficult on your test. So we're going to start having these conversations now. The area of the room is 396 square feet. The length is x plus 3. The width is x plus 7 feet. Find the dimensions of the room. Okay, the room is a rectangle. How do you find the area of a rectangle? Length times width. Right? What do we know to be the length? X plus 3. What do we know to be the width? X plus 7. What do we know to be the area? 396. Hey, does that help me find any of the dimensions? No, the way that it's written, I can't solve it. I can't solve a quadratic unless it's equal to what? 0. How do I make this equal to 0? Move the 396. Minus 396. Minus 396. Yes, I'm going to get that. So x plus 3 times x plus 7 minus 396 equals 0. Does that look like anything that we talked about yesterday?
Yeah.
No.
No. It looks like we did.
You've got partial factored, partial standard. So I can't solve this the way it is. I need to turn it into this and then refactor it. Because once I move 396 over, these are not my factors anymore. Those are the factors of the original. So we need to multiply this to figure out what we're really dealing with. So x plus 3 times x plus 7. Go ahead and multiply that for me really quick. Look at y'all. All right. X squared plus 10x plus 21. Now, add in the rest. Minus 396 equals 0. Let's combine some like terms. What's 21 minus 396? Negative 375. Okay, now I can find the solutions because now I have a standard form quadratic equal to 0. So we got to refactor. Hint, it's not going to be x plus 7 times x plus 3. All right, the new factors are not going to be the same. So a is 1, so we should be pretty quick through this one. If a is 1, I need factors of what? Negative 375 that have a sum of 10. And I'm going to use the area model, okay? So, negative 375, I told you the numbers are not always that nice.
Not always.
Say it again? 15 and 25.
How does he know that?
Okay, if a couple of things to think about when you're trying to find, it's negative 15. So when you're trying to find the factors, you really have to think about what the sum is, right? Because if my sum is 10 and I'm dealing with this huge value, I'm going to need like the middle of the range factors. I don't want like dividing by 2 or dividing by 5 because one of my values is going to be huge, the other one's going to be tiny. So you want like the middle range numbers that are pretty close together. So 15 and 25. 15 has to be negative because my sum is positive. So 25x negative 15x. What goes in my other buttons? X squared and negative 375. All right, that's not what I needed on the outside. I reused my area model. Sorry. There we go. So now I need to factor. What are my first two factors? Obviously, x and x. What is this one?
25.
And this one.
15.
Okay, so I've got x plus 25 times x minus 15 equals 0. So x equals negative 25 and x equals 15. Okay. Because you have to set them equal to 0, right? So x plus 25 equals 0, so you have to subtract. All right. Yes, it's a lot, but we're not done.
What?
We have to add it.
This is not very much enjoyable.
My length is x plus 3. What's x?
Negative 25.
Negative 25 or positive 15. Can I have two lengths of a room?
No.
Okay, so think about that for a second. If I plug in negative 25 and I plug in 15, one of them is unreasonable.
Yeah, you can't have negative.
You can't have negative distance. So which one of my x's for this problem is useless? Negative 25. I don't need this for this problem because I'm talking about dimensions. I'm talking about distance. So I need to take my 15 and I need to plug it back in. So 15 plus 3 is 18 and 15 plus 7 is 22. So what are the dimensions of the room? 15 or 18 by 22 feet.
I can figure that out. It seems so much more complicated.
Okay. It is a lot of work. And when we get into quadratic, most of them are a lot of work.